Hi everyone. Welcome to lesson 18 where we're going to talk about how to calculate your course grade and make decisions about that, and the concept of variation, which relates to statistics. It's like a brother or sister to talking about averages. Okay, so we've already talked about averages. So we've talked about the mean, median, and mode. Those are three kinds of averages. And I want to talk to you about another kind of average, which is a weighted average, and it's the most popular way to calculate your course grade in any course. So this is the grading scheme for our class specifically, but even if you're not in my class, you can pretend if this were your syllabus, if this were how your grade were to be calculated. Then what do these things mean? Okay, so there's an exam average that counts as 45% of your grade. That's almost half of your entire grade is just exams. And there are 3 exams. There's a final exam, that's 20% of your grade. There's some quizzes, some quiz meetings, some homeworks, and some classwork. Okay, so let's assume that so far these are the grades that you know, and let's calculate your course grade under the assumption that you haven't taken exam 2, 3, or the final, and you haven't done all the quizzes, and you haven't done all the homeworks. You also haven't done all of the classworks because the class is not over yet. But you have your classwork average thus far as 100% because you've been doing all the classwork. And then, oh, this should say percent here. Let's fix that. And then your meeting average is 100% because you've been coming to see me for your quizzes. And your homework average looks like it's also 100% if this were a hypothetical student. Okay, so how could we calculate your course grade? Well, since exams are 45%, then you would be doing 72% times 0.45 because they have a weight of 45%. And you've only taken 1 so far. The final exam you haven't taken, so we're going to leave that out for now. The quizzes, you need to find your quiz average. So you could do 60 plus 90 plus 100 plus 70, because so far you've taken 4 quizzes. And then multiply that times the weight of the quiz, which is 10% as a decimal, so 0.10 or 0.1. All right, and then you also have some quiz meetings. So you have, let's pretend that you've come to every meeting that you had to. So you have 100% for your quiz meetings, and they're worth 10%, so that's why I multiplied by 0.1 here. Then you have homeworks, but all of your homeworks, you could find that average, but so far, assuming that this student has done all the homework, the average is going to be 100 anyway. See all the hundreds here? And that's worth 10% of your grade. And then you also have some classwork, and the classwork, so far you have done all the classwork problems, so your average classwork grade is 100%, and it's worth 5% of your grade. So if you calculate all of this, keep in mind this does not include the final exam. Okay, so that's important because we haven't taken it yet. Let's see what we get. So 72 times 0.45. And you should go ahead and do this along with me just to make sure that you get the same thing. And I'll write what I'm getting here so that I don't have to keep track of it in the calculator. Put it down here. 32.4 plus 8 plus 10 plus 10 plus 5. Okay, so in other words, what we have so far is 65.4, but that's not out of the total 100% of the course because you haven't taken the final exam yet. So because you haven't taken the final exam, this is really only out of 80 possible points because the final exam is worth 20%. And I'm using the word points and percents here a little synonymously because I'm assuming that all of these are, 45 points, 20 points, 10 points, 10 points, 10 points, 5 points. So it's kind of a different conceptual way to think about the percentages. They still are a percentage, though. That's why we're multiplying all the grades here by their relevant weight. But if you think about it in terms of points, you have earned So this does not include the final exam, which means you have earned 65.4 points out of a total possible 80 points. And I'll put here because final exam is worth 20 points if you think about it like that. Okay, so this means your current grade would be 65.4 over 80. So let's see what that is. So that would be an 81.75. So we could say that your current grade is a B in the class. Now, that's without knowing all of these other grades that are going to happen at the end of the semester, right? So if you change, if you take exam 2 and let's say you get a 90, then, 90%, then that's going to change how much you just earned for the exams here. That's going to change what happens here. So instead of just 72, you should be doing 72 plus 90 divided by 2 because that's your new exam average. And let's just see how that would change your grade. So that would bring that up to an 81 average on your exams because this average here would become 81. And 81 times 0.45 is 36. So this, instead of 32.4, it would become 36.45. That would bring up your total here to be a little bit higher. So your total here would be 69.45. 69.45. And now 69.45 out of 80, because you've still only had 80 points because you haven't taken the final, brings you up, exam 2, this would bring you up to 86.81. All right, so that brings up your final grade there by about 5 points. So I wanted to share how you calculate course grades. One, just so that you know how to calculate your course grades in any class. It's helpful to know how to do that, and then you can check the instructor's, final grade that they have listed for you to make sure that you're getting what you earned. But I also wanted to go through some of these questions so that you understand how each one of these impacts your grade, because it might not seem as obvious until you actually break down the numbers. So how much is one homework assignment worth in your overall grade? So right now, I get this question a lot from students. They'll say, I missed a homework. Is that going to hurt my grade a lot? Like I have a 0%. Like what if this said 0? How would that affect your grade? Well, you can figure it out. You can figure out how this average would change. So if you did that new average, then you'd be doing 300% over 4, which brings your homework average down to a 75%. So instead of this being 100, this would change to 75. And instead of this down here being 10, this would end up changing, whichever one of these is 10, I think it's the first one. This would end up changing to 7.5 because now you don't have a perfect score for your homework. But does that change your grade much? It brings this down by about 3 points. And so let's just assume if you went down from a 69 to a 66, we'll just go 66 even out of 80. That still puts your grade at an 82.5, right? So you still have a B. So you missed one homework assignment, but you still have a B. And that's because your grade is calculated by taking into account the average homework grade of all your homeworks. So one homework grade, if you want the exact amount for how much it's worth, you need to know how many homeworks there are in the entire semester. There's about 12 in our class. So if they're all worth 10%, then that means one homework grade, if they're all worth 10%, you take the total 10% and you divide it by 12 because there's 12 homeworks, or roughly 12. All right, and that means each one is about 0.833%. So each homework, it's not even worth 1% of your grade. It's only going to affect your grade less than 1% of your grade. That's a difference from an 86% to an 85%, let's say. How much is one quiz worth? Well, you come up here and you see there's 10 total quizzes, and all together, the average quiz grade is 10%. So that means each quiz If you take 10% and you cut it up into 10 pieces, each quiz is worth 1% of your grade. What does that mean? That means if you get a 0 on a quiz, your final course grade is going to be 1% lower than whatever you earned. So if you earned an 86%, but you got a 0 on one quiz, that really means you got an 85%. That's not a huge difference, depending on if you're on the cusp or not. If you're going from a 79 to an 80%, then it makes a difference. But generally speaking, 1% is not a big difference. But if you start missing a lot of quizzes, like if you miss 5 quizzes and you have a 0 for all 5, now you have cost yourself 5% of your total grade at the end of the semester. So now that is a big deal. So students have also asked me, what if I don't do well on a quiz? Well, even if you get a 50% on a quiz, that means you earn 50% of this 1%. So if each quiz is worth 1% and you got a 50% on a quiz, you earn half of that 1%. So you just earned 0.5% towards your course grade. So the difference between a 50% on a quiz and an 80% on a quiz, you're talking about in the hundredths that you're changing your final score. So it's not seen as a big deal, and that's why I make quizzes worth only 10% of your grade and make sure that we have enough of them that each one by itself is not enough to impact your grade. So the point of quizzes in my class is to help you see what it is that you might still need to study. Like if you got above a B on a quiz, then that's great. You might not need to study that material very much. But if you scored below a B, especially if you got a D or lower, that shouldn't cause you to panic about your grade. It should cause you to go back and study that material a little bit deeper and a little bit more thoroughly to make sure that you understand, so that you don't make the same mistake on the exam, where it really matters. Of course, the exams are worth a lot. So one meeting grade here, you have about 10 meeting grades, so one meeting grade is still 10%. This is the same. You have about 10 meetings. You might have 9, I'm not sure. So that will make the quiz meetings a little bit higher than 1%, but they're roughly 1%. One exam, though, each exam, all the exams together are 45%. All the exams together are 45%, and you have 3 exams. That means one exam is just 15%, is 15% of your grade. That's not a just 15%, because that is a huge portion of your grade. So if you get a 0 on an exam, for example, then that means the highest grade you could possibly get in the class is an 85, because you have lost out on those 15 points, the way that I think about it. So the highest grade would be an 85, and that would be if you got 100 on every single other assignment. So if you miss an exam and you take a 0 for an exam, you're likely going to score less than an 85. It's very rare someone gets 100 on every single assignment, every single test, quiz, and the final exam. That's rare. And why is it right now that if you miss one quiz, it has such a big impact? Because we haven't had that many quizzes. So if we've only had 4 quizzes and, one of these grades gets changed to a 0, like if you miss quiz 2 and you have a 0, then of course that has a bigger impact on your grade now because we only have 4 quizzes. But at the end of the semester, when you have all 10 quizzes, 1 quiz is not going to impact your grade as much. So the more quizzes you stack on, the less one bad quiz would impact your grade. Okay, so that's a little bit about how course grades work. This is called a weighted mean. We're going to just look at one quick problem. If you want to earn a mean exam score of 80%, at least 80%, and you've earned 75% on exam 1, 70% on exam 2, then what do you need on exam 3 to obtain this mean score of at least an 80? So this is another question I've had students ask me. But because you know how to calculate a mean, you already know how to answer this question. If you don't know what x or what exam 3 is, then let's call it a variable. So let's say let x be your exam 3 score, since we don't know what it is yet because you haven't taken it. All right, well that means if your average is found by adding these together, not 80, 75 plus 70 plus x, we don't know your score on exam 3, so we called it x, divided by 3, and we want this to be at least 80. So we want that to be greater than or equal to 80 so that you have an average exam score of a B. Then let's go ahead and just solve this for x. So I'm going to just multiply both sides by 3. That gets rid of the 3 in the denominator here. I can add these two like terms here. So 145 plus x is greater than or equal to 240. All right, and then I'm still solving for x, so I can just subtract 145 from both sides. So 240 minus 145 is 95. So that means you have to get a 95 or higher on exam 3 if you want to have a B average on the exams. And the reason why you need such a high score here is because the first exam was in the 70s and the second exam was in the 70s. So before we even did this calculation, I expected that your third exam would have to be in the 90s to help meet those 70s in the middle where the 80s lie, since you're trying to get to an 80%. Okay, you'll see some problems like this in your homework where they're asking you, if I want a mean of some number, then what do I need on the last item in order to get to that mean? So you just let that value be a variable. Any variable you want. I used x, you could have used e for exam, or t for test. You can use whatever variable. And then you just solve that equation. Okay, so I hope that clarifies how your course grade is calculated and helps you to make decisions, because a lot of time when students are having trouble in college, it has nothing to do with intelligence, I have learned. It has everything to do with time management. And so it becomes a balancing act, right? How do you figure out what to prioritize in terms of your classes? And then on top of that, in terms of your personal life and your family and your friends and other obligations that you might have in your job, and it's just a very learned skill. It takes a lot of time to learn how to manage your time and to do so wisely. But if you understand how grades are calculated, then you can make a decision about whether you should work on writing an essay for a class where essays are worth 15% of your grade and you only have 2 of them, versus spending time working on a quiz that's only worth 1% of your grade or less, right? So that helps you to make more educated decisions about how to spend your time. So the next topic we're going to discuss in this lesson is variation. And so again, I said this is kind of like the brother or sister to the idea of an average. So the average is supposed to help us to understand the central tendency of any data set. So like kind of where is the center of the data? The variation tells us how spread out all the data points are from that center. So knowing both of those ideas gives us a good idea of the distribution of any data set without actually have to see all of the points in the data set. That being said, we're going to do an example to start where you do see all of the points in the data set. So I'm going to start with a question that helps us prepare about why we might need this concept. So here's 2 classes, and let's say these are their exam scores. Which class would you say performed better? Try and answer that question now. So this is a tough question because if you try and find the mean, which would probably be my first instinct, it looks like we get 7, 8, 9. There's 9 points. Okay. It looks like I got 75 for the first class, so they got a mean score of 75. And I calculated the second class, their mean, and I also got 75. So it seems problematic to use the mean to tell me which class scored better because it makes it sound like both classes scored equally well. But I would argue no, they didn't, as a professor. So then you might say, well, what about the median? Maybe there's outliers, so maybe we should use the median. But the median is still 75 for both classes, which makes it sound like they performed equally. But I would argue no, they didn't perform equally. And if it were me, I would say that class 1 performed better, just because as a professor, I want everybody to pass, and if a passing score is a C, then here everybody passed. But in class 2, there's quite a few people, 4 people, that failed if a C is a passing grade. It depends on, the course and what counts as a passing grade. But if we assume C is a passing grade, then there's quite a few people that have failed now. And then there's some people who did really well, right? Which didn't happen in the first class. So we need this idea of variation to help us understand that the average is not enough to tell me who performed better. What you could say instead is that on average, both classes performed equally well. However, Class 1 has a smaller variation because the scores are more consistent. Their scores are all really close together. In other words, the range of scores, it's only a difference of 5 from 74 up to the high score of 79. But for Class 2, these scores are varied. They're so spread out. They're so far from the mean. So it looks like the range here is like almost 40. Right? It's 37, jump from 63 all the way up to the highest score, 100. That is a huge spread. So that's what variation does. It measures how spread out the data points are. There are two calculations for the variation. One is called the range, and one is called the standard deviation. I actually just calculated the range for you for these two classes. It's the biggest number minus the smallest number. So the range of class 1 is 5, and the range of class 2 is 37. So this is the easier statistic to calculate. Standard deviation is the harder one. So let's do an example. Let's say you have two groups of dogs here. The individual weights of both dogs are listed below. So you have all these dogs. The first group has 5 dogs. The second group has 6 dogs. 1, 2, 3, 4, 5, 6. So let's find the mean and the range for each group of dogs. So pause your video and try that now. If you've never seen this notation before, this is called X bar, and it stands for the mean. So I'm just going to start getting us used to seeing the notation. So that's the mean of the first group, so we can call this X bar sub 1 if we want. And I'll do that calculation in a moment. And then here's the mean of the second group. So let's rewrite all of this. Over 6. Okay, let's see what we get. So I got 49 for the mean of the first group of dogs. 49 pounds, so we should specify that it is pounds. And for the second group, I got 49 as well. So it looks like both groups have the same mean. They have the same average weight amongst all of the dogs there. We could put pounds here for consistency's sake. And then the range is just the biggest number minus the smallest number. So we can call this the range of group 1. We'll call that R sub 1. So 65 minus 30, which is 35 pounds. Then we can do the same thing for the second group of dogs. We can call that R sub 2. And the second group is 125 minus 32, which is 93. Okay. So if you look at the answers that we got here, both groups of dogs have roughly an average weight of 49 pounds. Okay, so on average, the dogs in both groups weigh 49 pounds. But the first group has a range of 35 pounds. The second group has a range of 93 pounds. That is a very large range. And if you actually look at the groups of dogs, it actually looks to me like the second group of dogs has a more consistent weight, except for the 125. These have a more consistent weight. They're closer together than the first group, except for the 125. So what happens is that outlier of 125 throws off the range the same way that it throws off the mean. And it ends up looking like the second group is much more varied in the weights of dogs when really they're not. It's just one dog is very big. In other words, if you were going to walk this group of dogs, I would imagine that the first group, these 5 dogs are probably very different. You know, you might have like a Labrador and then, you know, a Husky, maybe a Poodle. You know, these are rough weights, so the names I'm giving are probably not appropriate for how much dogs really weigh. But in the first group, looks like you have a bunch of smaller dogs. So you might have like a bunch of the same dog, like a bunch of, I don't know what kind of dogs weigh that much, but they might all be Labradors. And then you have like a Great Dane or something that's apparently weighs a ton here. So the range is limited as a measure of variation because it is affected by outliers. The same way that the mean is affected by outliers. So that is a key concept for today. And it's the reason why it is way more popular to use the standard deviation. So standard deviation is another way to measure variation. And the way that it's calculated is pretty complicated. I'm not going to lie to you. So it's going to look really complicated what we're about to do. But conceptually, what it means is you are figuring out how far each value in your data set is from the center of itself on average. So in other words, the standard deviation is an average itself. So it's going to look like we're calculating a mean. So it's going to be, add a bunch of stuff on top and divide by the total number of things. It's going to look like that. And I want you to keep in mind what it means. So the standard deviation, it's an average measure of distance from the center of the data. So if you see this picture here, these are the first group of dogs. The dog is 30 pounds. It's up here. 30 pounds, 40 pounds, 50 pounds, 60, and 65. So each of these blue dots is one of those data points. And the X that I put right here at 49, that's the mean. That's the center of the data. And the standard deviation is calculating the distance between this point and the mean, and then this point and the mean, and then this point and the mean, and this point and the mean, and this point and the mean. So you figure out how far each point is from the mean, from the center, then you add them all up, and then you divide by however many you have. That's roughly what we're going to do, but not exactly correct. And the reason why we can't just add them all up the way I just said is because if you tried that, some of your answers would be negative because these values are less than 49. So if you do 30 minus 49, you're going to get a negative answer. And the rest of these values are positive. So when you end up adding up those differences, you'll get 0 because that's what the center means. It means it's the balancing point for how far away every point is from the mean. So what we do to prevent that from happening, from getting 0, is we square each of these differences. But because any number squared is a positive number. So we do that to make all these numbers positive. But in doing so, we've introduced some error into our calculation, so we have to correct that in some way. So here's the very complicated mess for what this formula looks like. So this symbol up top, this means sum. This means find the sum of each point minus the mean. So x bar, remember that stands for the mean, the average. So you're doing every point, subtract the mean, and then you're squaring it because we want all of the differences to be positive. Otherwise, we're going to add everything up and get 0, which is not good. We know that the variation is not 0. And then instead of dividing by n, the way we do when we find the mean, we're going to divide by n minus 1 to correct for this error that we introduced because we didn't really want to add them all up squared. That's not our intent. So to fix that, you can subtract 1 and it fixes this error that we introduced. Then the final step, because we squared everything, is to take the square root of everything. And then we'll have a good measure for how far each point is on average from the mean. So here we go. I kind of wrote this all out so you could see it. So the mean of the first group of dogs, which we did already, is 49. So you see how we find the mean? Add up. That's what that symbol means. It's like a Greek letter S. It means add up all your data points and divide by however many there are. So now we're going to find the standard variation. So each point minus the mean and then square that difference. So here you go. Here's the point 30. That was the first point. Minus the mean is 49. And then square that difference. Plus 40 minus the mean squared. Plus 50 minus the mean squared. Plus 60 minus the mean squared, and plus 65 minus the mean squared. So every point that you see up here, the 30, 40, 50, 60, and 65, those are all the same points down here and here. So to find the mean and to find the standard deviation, you're going to use those points. So you subtract those numbers. So like 30 minus 49 is negative 19, but I just wrote positive 19 because I know I'm going to square it anyway. So I wrote 19 squared. Same thing here. This is negative 9 squared, but I know I'm going to square it, so I just left it as 9 squared. 50 minus 49 is 1. 60 minus 49 is 11. And 65 minus 49 is 15. So you're going to square all of those numbers and add them up. And then we're dividing by 1 less than the total number of points. So we're dividing by 4 instead of by 5. So there's 5 total points, so we're dividing by 1 less than 5. Once you calculate this, which was already a doozy, that was a lot of calculation there. But once you get that, the final step to find the standard deviation is to just take the square root of that. So this whole calculation we did here, it has a name in statistics. It's called the variation. You don't need to know that unless you're going to take a statistics class, or maybe you're already in one. So then you'll need to know it for that class. But for my class, you just need to know how to find the standard deviation. So once you get the variance, you just square root that answer. So this means the dogs are roughly 14 pounds. Like each dog is roughly 14 pounds away from the center of the data. I'm not exactly explaining that correctly, but I'm trying to give you a rough idea that you can think about conceptually. So on average, all of these dogs, there's 5 of them, they're roughly 14 pounds away from the mean, which was 49 pounds. As some practice, why don't you try and calculate the standard deviation for the second group of dogs? So here it is. I'm going to pause my video and do it with you, and then I'll write out my work so that you can see it. Okay, so we already know that the mean is 49. And so I just started writing out all of the data points, 32 minus 49, 32 minus 49, 34 minus 49. I wrote all of them out, subtracting the mean, and then I'm going to square all of them. So the first thing I did in my calculator was I figured out what is the difference between all of those points. So I got 17, 17, 15, 14, 13, and 76. Now in my calculator I have to square all of those numbers and add them all up. So that means for the top I get 69.44. And the denominator is 5 because in this case there are 6 points. 1, 2, 3, 4, 5, 6. And 6 minus 1 is 5. All right, so I just wanted to show like this is where we are so far. And then if you divide that, you get 1388.8. So that is your variance. And then the very last step is to take the square root of that. So what is the square root of 1388? It's roughly 37.26. So that means the second group of dogs has a standard deviation of 37 pounds. That means on average, these dogs are about 37 pounds away from the mean on average. Okay, so this is a long, complicated formula. It takes some time to get used to doing it, so extra practice will be helpful here. And you can always look up other videos that might explain this in a different way that might make more sense to you. But that's how I've come to understand standard deviation. It's the average distance each point is from the mean. And these are just 2 summary questions to kind of wrap our minds around. Do we really understand what it means conceptually without having to do any calculations? So if you look at this question, here are those 2 classes, the same 2 classes from above, and they have the same mean. Which class would have a smaller standard deviation? And the answer is class 1, because these points on average are closer to the center. They're closer to the mean of 75. Class 2, those points are far from 75. So 63 is farther from 75 than 74 is. 74 is only 1 point away from 75. But 63, that's more than 10 points away from 75. So class 2 has a larger standard deviation, which means class 1 has the smaller standard deviation. And finally, this was a little tricky for me. If you look at these bar graphs here, think about how you would find the mean of these bar graphs. So this means, 2 people scored roughly 74%. This means 7 people scored, 74%. 8 people got 75. 8 people got 76. 12 people got 77. And I'm just estimating based on what I see. Over here, this means 12 people scored a 71. 13 people scored 73. 12 people scored 76. So that's how you read the bar graph. This y-axis tells you how many people scored the scores that are down here on the x-axis. So knowing that, and knowing that the standard deviation is a measure of how far away points are from the mean. So the more points that are far away, the larger the standard deviation is. The closer the points are to the center, to the mean, the smaller the standard deviation is. So out of these two bar graphs, so on the section 1 and section 2, which class has a larger standard deviation? The answer is section 2. They have a larger standard deviation because the mean is probably around 80. It's probably somewhere in the middle. The same thing here. The mean is probably around 80. It's probably somewhere in the middle of this whole distribution. And if you look at section 2, there's 12 students that are very far away from the middle, from 80. And there's 12 students on this side that are also very far to the right of 80. But when you look at this bar graph, a lot of the students are very close to 80. Like there's like 17 students are close to 80, and then 14 students are really close to 80, and then 12 are close to 80. So like there's 30 students are like already very close to a score of 80. They're closer to the middle. And if you go farther to the outsides, there's only like one student out here that's far away from 80, compared to 12 students over here that are far away from 80. So section 2 has a larger standard deviation. It's tricky because when you look at the bar graph, the bars look more consistent. So they look consistent, but the bar graph, it doesn't tell you about the consistency of the data. It's telling you there are 12 people with this score, and another 12 people with this score, and another 12 people with this score. So while the heights of the bar graphs might be consistent, the actual scores, if you were to list them all out, you would list the score 71 12 times. That would be a lot of people very far away from the mean of 80. Okay, so be careful when you see, like, these are called uniform bar graphs because they have like a uniform looking height. Uniform bar graphs have very large standard deviations because lots of people are far away from the middle. Whereas a bar graph that looks like this should have a smaller standard deviation because more people are in the middle because these peak heights here are close to the middle and high. If you had a bar graph that had just a single bar, like if I were to show you over here and I make like a hypothetical bar graph, if you had a bar graph that looked just like this, and it said, 60 people, and let's say, you can't see that color green very well. I'll make this a little bit stronger. So if you had a single bar graph, okay, so just everybody is right there in the middle, and everybody scored an 80, that distribution would have a standard deviation of 0 because everybody scored the same exact score. There is no variation. Nobody is far away from the mean. So once I understood that concept, that helped me when I was doing problems like these to understand the distributions that are uniform like that will have a much larger standard deviation because everybody is so far away. Okay, so those were the two main concepts for today's lesson. So we talked about how to calculate your course grade, which is another kind of mean. It's called a weighted mean. And we talked about the idea of variation. And there are two measures of variation. There's the range, and then there's the standard deviation. So those two measures, they both measure variation in some form, but the range is usually not a very good measurement because outliers affect it enormously. The same thing like with the averages. So now you know 3 averages. If you want to count today's lesson, you know 4. So you know the mean, the median, the mode, and now you know a weighted average, which is popular for course averages. So you know all 3 averages, and you know that the mean is very strongly affected by outliers, whereas the median is not. Same thing with range and standard deviation. The range is affected by outliers, but the standard deviation, not so much. It still is, but not as much as the range. Okay? And in our next lesson, we are going to talk about more about bar graphs and other kinds of charts and how to create frequency tables and histograms, and making sure that we understand what we're looking at when we see graphs and charts in real life.